Have you ever wondered what makes a car move? It's a question that might seem simple at first, but the answer is anything but. Beneath the sleek exterior of your vehicle lies a world of complexity and precision engineering. Every time you turn the key, a symphony of parts comes to life, each playing its own crucial role in the performance of your car. It's not magic, but a complex system of interconnected parts all working together. From the engine to the exhaust, from the transmission to the tires, every component has a specific function. These parts are meticulously designed and assembled to ensure that your car runs smoothly and efficiently. Imagine the car as a living organism, where each part is like an organ, vital to the overall health and functionality of the vehicle. This essay will take you on a journey to understand the main components of a car, like exploring the different instruments in an orchestra. Just as each instrument in an orchestra contributes to the harmony of a symphony, each part of a car contributes to its overall performance. We'll break down the car into its essential components, giving you a deeper appreciation for the engineering marvel that is your vehicle. We'll start with the chassis, the car's foundation. The chassis is like the skeleton of the car, providing the structure and support needed for all other components. It's designed to be strong and rigid, yet flexible enough to absorb the shocks and stresses of the road. Without a solid chassis, the car would not be able to maintain its shape or handle the forces exerted on it during driving. Then we'll delve into the powerful engine, the heart of the operation. The engine is where the magic happens, converting fuel into mechanical energy that propels the car forward. It's a marvel of engineering with countless moving parts working in perfect harmony. From the pistons to the crankshaft, every component of the engine plays a crucial role in generating power and ensuring efficient performance. We'll learn how the transmission and drivetrain transfer power to the wheels, allowing the car to move. The transmission is responsible for adjusting the power output of the engine to match the speed and load conditions of the car. It ensures that the engine operates within its optimal range, providing smooth acceleration and efficient fuel consumption. The drivetrain, on the other hand, transfers this power to the wheels, enabling the car to move forward or backward. And how the fuel system keeps the engine running. The fuel system is like the car's circulatory system, delivering the necessary fuel to the engine for combustion. It includes components like the fuel tank, fuel pump, and fuel injectors, all working together to ensure a steady supply of fuel. Proper maintenance of the fuel system is crucial for the engine's performance and longevity. Next, we'll explore the suspension, which ensures a smooth ride. The suspension system is responsible for absorbing the shocks and vibrations from the road, providing a comfortable and stable ride. It includes components like the springs, shock absorbers, and control arms, all working together to keep the car's wheels in contact with the road. A well-maintained suspension system is essential for the car's handling and safety, and the steering system, which allows you to control your car's direction. The steering system is like the car's nervous system, transmitting the driver's inputs to the wheels. It includes components like the steering wheel, steering column, and steering rack, all working together to provide precise and responsive control. Proper maintenance of the steering system is crucial for the car's safety and performance. We'll also uncover the electrical system, the car's nervous system, which powers everything from the headlights to the infotainment system. The electrical system includes components like the battery, alternator, and wiring, all working together to provide power to the car's various systems. Proper maintenance of the electrical system is crucial for the car's reliability and functionality. And finally, we'll step inside the car to look at the interior and its many features. The interior is where the driver and passengers interact with the car, and it includes components like the seats, dashboard, and infotainment system. A well-designed interior provides comfort, convenience, and safety, making the driving experience enjoyable and stress-free. Let's begin our journey into the fascinating world of car anatomy. By understanding the various components and systems that make up your car, you'll gain a deeper appreciation for the engineering marvel that it is. So buckle up and get ready to explore the intricate and fascinating world of automotive technology. Imagine a car without a skeleton. It wouldn't hold its shape, would it? That's where the chassis comes in. It's the car's backbone, providing structure and support for all other components. The chassis comprises two main parts, the frame and the body. The frame is like the skeleton itself, a rigid structure usually made of steel. It absorbs impacts during accidents, keeping you safe. The body is what you see, the outer shell that gives the car its shape and style. It's usually made of steel or aluminum and houses the passengers, engine and other components. Think of it as the skin and muscles that cover the skeleton. Together, the frame and body form the chassis, the foundation on which the rest of the car is built. The engine is the beating heart of your car. It's a marvel of engineering, a symphony of metal and fuel working in perfect harmony to propel you forward. Without it, your car would be nothing more than a lifeless shell. It's where fuel is converted into energy that powers the wheels. This process begins with the fuel injection system, which precisely measures and delivers fuel to the engine. The fuel lines, like veins, carry this vital liquid to the heart of the machine. Imagine it as a powerful pump that draws in fuel and air, mixes them, and ignites the mixture to create energy. This energy is what drives the pistons, which in turn move the crankshaft, ultimately turning the wheels of your car. There are different types of engines, but the most common ones are gasoline and diesel engines. Each has its own unique characteristics and advantages. Gasoline engines are known for their high-speed performance and quick acceleration, while diesel engines are celebrated for their fuel efficiency and durability. They work on the same principle, but use different fuels. Gasoline is a lighter, more volatile fuel, which makes it ideal for engines that need to rev quickly. Diesel, on the other hand, is denser and contains more energy per gallon, making it perfect for engines that need to deliver steady, long-lasting power. Think of gasoline as a quick burst of energy, like a sprinter, while diesel is more like a marathon runner, providing steady power over a longer time. This is why diesel engines are often found in trucks and heavy machinery, where endurance and efficiency are key. Inside the engine, pistons move up and down within cylinders, compressing the fuel-air mixture. This movement is the core of the engine's operation, transforming chemical energy into mechanical energy. This compression creates heat which ignites the mixture, causing an explosion that pushes the pistons down. This explosion is the driving force behind the engine's power, a controlled burst of energy that propels the car forward. This downward motion is converted into rotational force that ultimately powers the wheels. The crankshaft translates the up and down motion of the pistons into a circular motion, which is then transferred through the drivetrain to the wheels, making your car move. Section 4. Transferring power, transmission and drivetrain. Now that the engine is generating power, how does it reach the wheels? This is where the transmission and drivetrain come in. The transmission acts like a gearbox, allowing you to select different gears for different driving conditions. Think of it like shifting gears on a bicycle. Lower gears provide more power for starting and climbing hills, while higher gears allow for faster speeds on flat roads. The drivetrain then takes this power from the transmission and sends it to the wheels. There are different types of drivetrains, including front-wheel drive, rear-wheel drive, and all-wheel drive. Front-wheel drive sends power to the front wheels, while rear-wheel drive powers the rear wheels. All-wheel drive, as the name suggests, powers all four wheels, providing better traction and control in various conditions. Section 5. Fueling the journey, the fuel system. In this section, we will delve into the intricate workings of a car's fuel system, a vital component that ensures your vehicle runs efficiently and reliably. Understanding how the fuel system operates can help you appreciate the engineering marvel that powers your daily commute. Just like our bodies need food for energy, car engines need fuel. This fuel is the lifeblood of the engine, providing the necessary energy to keep the car moving. Without a properly functioning fuel system, the engine would be starved of fuel, leading to poor performance or even complete failure. The fuel system is responsible for storing and delivering fuel to the engine. It consists of several key components, each playing a crucial role in ensuring that the engine receives a steady supply of fuel. These components include the fuel tank, fuel pump, fuel lines, fuel filter, and fuel injectors. It starts with the fuel tank, where the fuel is stored. The fuel tank is designed to safely hold the fuel until it is needed by the engine. Modern fuel tanks are made from material that are resistant to corrosion and are designed to prevent leaks, ensuring that the fuel remains safely contained. From the tank, The fuel is drawn by a pump and sent to the engine through fuel lines. The fuel pump is a critical component that creates the necessary pressure to move the fuel from the tank to the engine. There are different types of fuel pumps, including mechanical and electric pumps, each with its own advantages and applications. Think of the fuel lines as arteries carrying blood throughout the body. Just as arteries transport oxygen-rich blood to various parts of the body, fuel lines transport fuel to the engine. These lines are designed to withstand high pressure and are made from materials that prevent fuel from evaporating or leaking. Before reaching the engine, the fuel passes through a filter that removes any impurities, ensuring smooth engine operation. The fuel filter is essential for protecting the engine from contaminants that could cause damage or reduce performance. Regular maintenance and replacement of the fuel filter are crucial for keeping the fuel system in top condition. Once the fuel reaches the engine, it's mixed with air in the correct proportion by the fuel injectors. The fuel injectors are precision devices that spray a fine mist of fuel into the engine's intake manifold. This mixture of fuel and air is critical for efficient combustion and optimal engine performance. This mixture is then ignited in the engine's cylinders, producing the energy that powers the car. The combustion process generates a controlled explosion that pushes the pistons, creating the mechanical force needed to turn the wheels. This is the heart of the engine's power generation process. The fuel system plays a crucial role in ensuring a constant supply of fuel to the engine, keeping your car running smoothly. Regular maintenance of the fuel system, including checking the fuel pump, lines, filter and injectors, is essential for the longevity and performance of your vehicle. By understanding and caring for your car's fuel system, you can ensure a reliable and efficient driving experience.